Here's another example of inter-process communication and how to talk between parent and a child and how to wait between parent and a child. So remember, as soon as you fork off a child, they do not share any memory space. It's a separate process on the process stack. So somehow we need to be able to catch from the parent when the child terminates, and also do some very basic passing of information between parent and child, such as return values. So here is an example of a simple code that will do nothing other than fork off a child. Child does some work, non-blocking, and parent will also do some work in the background. And at a certain time, child will exit and return a value to a parent. So in the main, we will do a very simple statement before we start forking off children. Just print before forking off a child. So then we will create a child and save the children's process ID into a local variable. If for whatever reason we cannot fork off a child, so if the return value is less than 0, then we catch an error and print error saying could not fork off a child. Otherwise, so anytime we have a, that's a wrong comment. Otherwise, if we are, if the PID is 0, I know that I'm talking to a child, so nothing, child will not do anything other than just print hundreds times its loop iteration, its ID, the fork, so the parent's ID, and get process ID from off the child of itself. And then when we are done, we can return a value. So let's return 12. It doesn't matter. So as soon as this code executes independently or independently of the parent, so at the same time, then we will terminate, the child will terminate with the exit value 12. Meanwhile, parent will do a very simple loop. It will just keep on printing that it's parent executing. But then the parent will wait for a child to finish. So in order to wait for the child to finish, we'll use the system call WaitPID, and we will give it a PID of a child that we forked off. To catch the return value of the child, we will say we will exit with the exit code 12. We'll create a local variable status, and we will catch the return value when the WaitPID gets the signal from the child process ID that it terminated. It will catch value 12 in the status, and then as long as the status is greater than 0, so non-negative, we will print the status value. So we created a local variable, we caught the value, made sure it's a valid value, and then we print with exit status value of the status. So that's the simple code. Most important thing here is to watch how synchronously child executes and how synchronously parent executes. So we should see these interleaving print statements that whenever child gets a time on the processor, it will print this long line. When the parent gets a time slot on a processor, it will simply print parent. So in the printout, just let's focus on watching who is processing when by simply inspecting these very simple printout statements. So let's make wait. So that's my code, and we can now execute. So that was pretty fast. So when we go way back to the very beginning, we I better save this first. Let's recompile. And there we go. So when we go way to the very beginning, we see that the first line, as a matter of fact, is before forking of a child, and parent is being printed first. It just happens, but it happens for a good reason. So it does take the operating system a little time to create a new process on the child on the stack. So that's why parent happens to start printing first. So there should be at least several parent prints, and all of a sudden we start seeing these lines, and that's when a parent process get evicted from the processor, and a child process is now placed in a process, so it starts printing its information in the main block of the child inside of the loop, which is this simple count statement. Then the child gets evicted, and parents get to print or get time on the processor. Then parents get evicted and child processes, and this way you can see how the child and parent processes will interleave the processor. And then parents started processing first, and if you notice, the both parent and child run 100 printouts, and then the rest of the code, or the rest of the execution, is the child printing out. The very last statement is child exiting with 12 as an exit value. Parent will not terminate, but here it will block and wait until the child process finishes processing, and it will catch the return value of the child process. And then, as long as the value is greater than 0, then the status of the child is printed. So it did catch 12 in the local variable status, and child exited with status 12. So here's an example of a very simple parent-child forking and interleaving of the processes, as well as some very fundamental communication between child and a parent with passing the values, exit values between child and the parent waiting for a child to process and finish, catching or waiting for the child's PID and catching the return value. So this should also be very helpful when you're working with child and parent processes. Make sure that you do not leave processes basically running in the background because parent finish and the child would never finish off. So this wait PID is a very useful system call.